Let's say we are asked to write a pseudocode to find the second largest of four unequal numbers. So we could assume that the numbers could be represented by the four variables a, b, c, and d. So for example, in this line 6312, the second largest would be d, which is 2. We're not interested in the variable name, but we are interested in the value 2. So in order to find the second largest, I am going to use two other variables called as large and second large. So what I am going to do is I am going to process one variable only at a time. So the logic is going to be like this. When I have looking at A, I am going to assume my large is also A as well as my second large is also A, assuming I am taking this line. Now, next when I take a look at B, I need B can be either greater than the large or it can be lesser than the second large, because right now both the large and second large are the same. Suppose B is bigger than the large, then I will replace this with B. Suppose B in this case, for example, is smaller than the second large. So in this case, my second large would have been 3. Now I am done processing B. The next step what I do is I take a look at C. Now C has two cases. C can be greater than the large or C can be greater than the second large. In case C is greater than the large, then what happens is this C will replace this large and large will end up becoming second large. This same approach again is used for D. D is first compared with large. If D is bigger than large, large is replaced with the value of D and D is moved to the value of second large. This will be clear in a minute when we develop the pseudocode logic and then we do a couple of tests. So my first step if I have to do a pseudocode is I am going to consider four variables a, b, c, d and two extra variables large and s large to store the largest and second largest values. I am going to then ask the user enter the values into a, b, c, d. He could enter any of these kind of values assuming that got to be unequal into a, b, c and d. Now since I am processing one variable at a time, so in the first step, as I told you here, my large is going to be A as well as my second large is also going to be A. So this is step number 3 and 4. So at this step, A is assumed to be large as well as A is assumed to be second large because I have not seen any other number at this point of time. Now the next step, as I told you, I am going to compare B with large. If B is bigger than large, then this large will be replaced by the value of B and nothing will be done to second large because second large remains as it is, because second large was already the old value, it will remain as it is. So if B is greater than large, then what I am doing is I am copying the value of B to large. So this takes care of a case like this one. For example, this takes care of a case like this one where initially large would have been 1 and second large would have been 1, but B is greater than the large one, so B will take the value of large here. B will be 2 and second large will remain 1, which was the value of A. Now there is one more case like this one, 6 and 3. B can be smaller than second large. So yeah, because second large happened to be 6, so I will replace 6 with 3. So this is how it works. If B is smaller than second large, then the value of B is copied to second large. So now I have taken care of A, I have taken care of B. Now it is very easy. I have to just look at C and D. The logic which is applicable to C will also be applicable to D. So what I am doing with C is, if C happens to be bigger than the large, okay, then what I am doing is I am going to display the large to second large and I am going to make the new value of large as the value of C. So let's see how that happens. If C is greater than large, then second large will take the current value of large and large will take the value of C. So this is how I handle a case where C is greater than large. Then the next case, C can just be bigger than the second large, not the large. So if C is greater than the second large, then I only replace the second large with C. So if C is greater than second large, then the value of C is copied to second large. Now we are only left with the value of D. Now D is going to be processed in a similar manner to C. If C is greater than large, then the value of large is copied to second large and the value of D is assigned to large. The last step, eighth, is, or the else part is, if D is greater than second large, then the value of second large is changed with the value of D. Finally, in the eighth step, I am going to display the second largest value is S large and stop the pseudo code. Now the only way to understand this particular logic is to run through a set of samples. So let's first take this first line. Okay, so A is large. So what I will do is A is 6, second large is also 6. Now is B greater than 6? Is 3 greater than 6? No. So else condition. Is B smaller than second large? Yes. So my new second large is going to be only 2. That's why you're seeing I'm only replacing second large with B. So this takes care of 6 and 3. Okay, this is 3, not 2. Then I come to the next step. I am done processing A, I am done processing B. Let me look at C. Is 1 greater than 6? No. Else if. Is 1 greater than 3? No. So I don't worry. Then I come to 2. Is D 2 greater than 6? No. Is 2 greater than 3? No. That is the second large. So then at this moment my second large is 3 and it's going to print the output as S large as 3. Now let's take one more different line. Let's take this line here. So in this case, what I'm going to do here is my large and second large initially are going to be 1. Because I'm assuming large to be 1, second large to be 1. Now the next question is this 2 greater than A? Yes. This condition here. Is B greater than large? Yes. 2 is greater than this 1 large here. So I will just replace this 2 and the 1 does not change because 1 is my current second large. So I have processed B now. I come to C. Once I come to C, I am checking C, the value of C here, 3 with the large. 3 is greater than 2? Yes. So what will happen in this case is now my new second large is going to become 2. This fellow will move here. Okay. And this fellow will be replaced by the value of C, which happens to be 3. Okay, which happens to be 3 and 2. So large is 3, second large is 2. Then I come to the seventh step. Now D is larger. Is 4 greater than 3? Yes. So second large is replaced by the current value of large, which happens to be 3. Then what happens to large? Large is replaced by the value of D, which happens to be 4. So my second largest in this case happened to be 3 and it's going to print the value of second largest as 3. Okay, this way you can play around with different cases and you will see that in every case this particular logic, take any combination of 4 unequal numbers, it will give you. The critical step to understand is initially you need to assume both A is large and second large. And when you're looking for B, look at the numbers. Suppose A was 3. So the large would be 3 and second large would be 3. Now when you look at 2, now there is 2 possibilities with B. B can be bigger than this fellow. If it is bigger, then what I will do is I will just change this fellow and make him the value of B. Or B can be lesser than second large. Okay, either bigger than this fellow or lesser than this fellow. If he is lesser than this fellow, I'll replace them as in this case and make him 2. So once you do this, I have tackled A and B. C and D is easier because for C and D, I need to compare whether the value of C is greater than large. If it is greater than large, I'll replace the second large with the current value of large. And the new value of large is going to take the value of C. The same process is going to be repeated for D. So this is the pseudocode to find the second largest of 4 unequal numbers.